Welcome everyone to another presentation up to the time. Today we are going to be looking at timber pitch roofs. So the first thing we always like to ask ourselves, what is a timber pitch roof? But before we get into that, let us first define what a roof is. Roof means the exterior surface on the top of a building. This does not include floors or formwork, which, because a building has not been completed, temporarily becomes the top surface of a building. What is a pitch roof? A pitch roof is a covering for a house or building with a peak or sloping surface of over 10 degrees, and builders commonly use them on residential homes. So now at this moment, I would show what a pitch roof looks like. So I have some examples down here. So the first thing is I can show you all, let's just go here. This is a pitch roof and we are looking at the roof from inside. And as we are here on the inside, let me just take up my annotations and let's have a look at what we see. What do we see? Spotlight. Good. So we can see here, these are the rafters. And behind the rafters, you'll get the close board. And then this is the wall here. Then we have some openings. That's a door, and this is a large window. And this is what a pitch roof will look like from the inside. Let's go down. And here's another example where we can see both the inside and the outside. This area here is called the overhang. Some people call it the eave. And in this roof, we can see that there's a light here. Let's look at another example. Okay, well, this is a roof detail, which shows the battens. It shows the common rafter. It shows the roof covering, which is usually metal. Actually, some people use clay tone tiles, Spanish tiles, to give it a different aesthetic. But usually you would find metal sheeting, or better known as galvanized. Eave and the wall plate. This wall plate is very important. We would cover this more because we are going to be creating a roof detail which actually carries a wall plate. And this is a lean-to roof, meaning it only has the pitch on one side. Right? And of course, if we wanted to see where the water would flow, let me just indicate the water would come here, drop down here, and then it will flow down here. This roof, however, doesn't have a gutter. Let's look at a roof detail with a gutter if we can find one. Now, this is a pitch roof being assembled, and these are called trusses. And when we see the truss, we also see the hurricane straps. So these metal plates are called hurricane straps. They actually help to create a better structural system for the roof. Let me just clear the screen. And these are some buttons here. These are buttons, and these are usually represented with an extrudent. These usually come in at 30 by 50 millimeters. This is the roof sheeting material that we will put at the end. So this is the permaclad, and this shows the thickness of the permaclad too. And this is really interesting. The thickness here is 0.5. If you look at the thickness, so it's really thin. I showed my students this and they couldn't believe that the metal sheeting could be that thin. Now let's take a look at this. This diagram gives us a lot of information. So let's read from the left to better understand this information. Now, what do I see here? I see the hip rafter, which is right here. And I also see the wall plate. So I'm going to clear and put in the wall plate. The wall plate is here, which supports the hip rafter and the common rafters. What else do I see? I see the common rafters, which are along here. Yeah, common rafters. I'm going to put the valley rafters in purple. The valley rafter comes off this valley. This is a valley here. And what do we mean? That's a point in the roof where water would be able to channel down that valley. This is probably the best way you can explain it so that people would understand. So the water from here, and it would channel in this direction. Let me use an arrow to indicate the direction. And if you wanted to, right here would be a good spot where I have this X with my arrows in yellow to place your gutter at that point there. Okay. Now, what else do I see on this? I see a ridge board. This is the ridge board here. And also here. I'll be thicken that up so you can see that better. That's the ridge board and the ridge board there. All right. Now, there are terms that mean the same thing. Let me just explain these terms. Sometimes you will see on diagrams the word purling. Purling is the same thing as laths, L-A-T-H-S, laths. And that also means the same thing as battens. So I don't want my audience to get confused whenever they see purlings or battens or laths. They all mean the same thing. And there are some supports that actually are placed above the rafters for the purpose of receiving the galvanized sheeting or the metal sheeting, which is the final layer of the roof. So those actually support the metal sheeting that is placed on top of the roof. That's the purpose of those purlins there. Let's go down the line and okay, so I think I can move off this image. These are typical tongue and groove boards that will be used up top the rafters. All right, so I have shown you all examples of all the materials that will be used on a pitch roof. Now, let me just go into a model here that I have created. And let's look at this pitch roof with all the members and everything assembled. So what do we have here? Let's orbit this and have a look and see what we have here. Okay, so let me just stop it here. All right, this is a good angle. And let me just describe what I can see. Now, this, let's start with that. That's the beam. That's the beam. So I'll put here beam so that people will know. Beam, capitals, B-E-A-M. That's the beam, and that's filled with concrete. What else do I see now? This is my wall plate. The wall plate. And this wall plate is made out of timber. And it comes in at a size of 100 by 50 mil. Size of my wall plate. And directly above my wall plate, we would see a hurricane strap. So that's my hurricane strap. hurricane strap there. And the hurricane strap is connecting the wall plate to the rafter. Let me show that. I'll show a yellow diagram to show this. So this is here, and then there. It's connected right here. So these two members are connected by that hurricane strap. So let me now identify the rafter for those. So this is the rafter here, right? This member, that's the rafter. And that comes in at a size of 150 mil. Right? And when I say 150 mil, for those of you that might be lost, I mean, that's 150 mil. Let me just write that there, because I want you at home to fully understand it. Should probably put that in white. Yeah, that's 150 mil right there. Okay, let's move on and see what else we can identify. And those are the close boards. Close boards. Put this back in red. Those are the close boards there. And actually, those come in at 125 mil long with a thickness of 25 mil. Yeah. Close boards in, and directly above the close boards, we would find this. Let me just pull that there so that better understand what we're showing. And that there is our button, or la, or purling. Let me put all the terms that can be associated with that. Purling, la, slash button. And that comes in at 30. On this diagram is 30 by 50. 30 by 50. All right. What else can we identify before we leave here? We can identify the roof. So now we get to the roof. This is the metal sheeting. Metal sheet. And I have exaggerated the thickness. I've seen that the thickness of this is between 0.5 to 2 mil. Right? I have exaggerated thickness so that we can actually see this properly. So, and this is what I was explaining, the real purpose of the buttons. So you can see these are the nails right here. Let me use a different color. So these are the nails right here, right? And you can see these are the nails. These nails go in to the button. So these nails go directly into the button. And the purpose of this is we do not want the nails to go into the closed boarding, because if we look at what's going on here, and we can clearly look from here, we can see that if we are on the inside, the closed boarding is what we are going to be seeing if we look up at the roof. So in the event that there is a leak, right, we wouldn't want that the leak seeps through this opening and then drips in to your internal space. So by driving the nail into the button, this prevents the nail from directly contacting the closed boards, right? And that's the purpose. We don't want the nail to touch the closed boards and to have any penetration, so that if water enters, it doesn't get in through here, right? So that is why we don't directly put the nail into the button, so as to prevent that. I hope everyone understood this diagram and how things are put together, and also the names and the sizes of these parts. Now, lastly, let's look at the eave. What's happening over by the eave? So if we look here, we will see this, right? By the eave. And this is the eave. Yeah. And this expression is known as a closed board. So we call it, a closed eave. A closed eave right here. What this means is that if a person were to stand up and look at the eave, you wouldn't be able to see into the eave because the eave is closed. It's not exposed. You wouldn't be able to see the rafters at all. And this is pretty good because this prevents small creatures like birds from coming up in here and creating a home when it's exposed. Sometimes birds and other small creatures hang out up in there. But when you have that closed, you don't experience that problem. And lastly, what do we have here to the left? Let me just clear the drawings. We have a gutter right here. That is the gutter. The gutter receives the water and channels it down to the ground. That's the gutter there. All right. Let me just explain how this works. The gutter. Most people should know this. The rain falls here on the gutter, the rain falls on the roof, and then gravity brings it all in this direction down. Use the arrow, then it hits the gutter, and then it goes. The gutter is attached to a downpipe, and the downpipe sends the water down to the earth. All right. So now I've explained the model. Now let us look at a strategy for drawing an orthographic and an isometric projection of a roof detail, of a closed eave detail. So let's look at this now again. So we can see over here we have our isometric pitch roof, and we have our orthographic pitch roof. And over here we have the same thing. Now what's the difference between these two drawings or these four drawings? Well, the ones on this side, to the left side, the pitch roof has been done without a wall plate. The ones on the right, the pitch roof has been created with a wall plate. We'll be focusing on creating the pitch roof with a wall plate today. The reason why I'm focusing on that is because CXC generally asks students to create pitch roofs with wall plates. So I want to prepare my students and my audience for that whenever it comes. So let's look at this detail here carefully and see what we can take away from here. We have the concrete wall, the block wall, which is 150 mil. And we have a layer of plaster, 10 mil on each side. The yellow lines, I just highlight them. That's the plaster layer. The concrete beam is 275. The wall plate is 100 by 50 mil. We get a hurricane strap up here. We have the rafters, 150 mil for rafters. And we have our closed boards coming in at 125 mil. And the aluminum sheet at the top. Then we have our buttons, glass, purlins right in here. Now, we're going to create, what's the strategy? We're first going to draw this pitch roof with a wall plate. Then we're going to draw this isometric with the same wall plate. So this is the finished result. And without any further ado, let us start this now. So I'm going to draw over here so that we can always reference everything that is being done. Let's start. So we know our walls are 150 alpha line. I'm going to start in my construction layer, alpha line, and I start project line upward. Doesn't matter what distance I would trim. I'm not interested in the distance going up. I'm just interested in getting a line onto the page. And I keep telling students, stop being interested in distances. It's foolishness. Just draw, and then you can trim and create a distance. Right? So this is just a line, no distance. Now I'm going to offset, to offset 150 is my first distance. Now this is a specific distance that I have to use. So 150 to the left, that creates my wall. Now I'm going to offset 10 mil on each side to create my plaster. 10 mil, 10 mil. Now, again, I'm going to find a line. I can project the line from this line across, and that is where the bottom of my beam would be. Now I'm going to offset, and the beam that I'm going to be using is 275. So I'm going to offset 275 up. Bam. That's my beam there. Then I'm going to do some trimming. Trim, trim, trim. So the sizes that I have that you see here are the sizes that I'm using. If you don't see me have a size, that means it's random. Let me just adjust this where the beam ends. And at the end of all this, I will place these into the respective layers. So right now I'm just drawing, and then I'll place them into the proper layers. Now, this is very important right here. This tells us that the pitch of the roof is 30 degrees. So we need to create that. How are we going to do that? Do we want to create the pitch of the roof 30 degrees? Or should I create the wall plate? I think I'm going to create the wall plate. Let me just measure a distance and see. And prove that this is 50 going up, and then it's 100 going across. So basically, vertically, 50, horizontally, 100. That's my wall plate there. And now, let us create my 30 degrees. So where do I go to start my 30 degrees? I'm coming at this point here. You know what? Let me put on my point system so that if I need to place a point to show the audience where I'm starting, I start right here at that point. That is where I start my angle. Click here, and I press Shift, less than symbol, and then you're punching 30 degrees. And that's how I get my 30-degree angle there. All right, no problem, not too hard. But if we look at this 30-degree angle is slightly above the wall plate. We would adjust all that later. Now from here, I'm going to offset this 150 so I can get the thickness one time. That's the thickness. All right. And then I want my overhang to be 300, sorry. What is my overhang? If you all remember when I explained the overhang is this area here. The area between, okay, let me use a different color. This is the overhang here, between here and here. That's the overhang, or better known as the eave. That distance is going to be 300. I didn't have it on the sheet, but let's put that in. Offset 300. And we offset 300 from this wall. We can either offset it from the plaster or from the actual wall, the structural wall. I'm going to offset it from the structural wall. That's 300. Now I'm going to extend these lines to reach there. You see? So that's there. There. Perfect. And then I'm going to fill it. Good. That's in place. Now, what I need to do is start to put in the close boards. these close boards are coming in at 125 by 50. So that means I need to offset the 50 up 50 mil. Let me just see what happens. I'm going to offset this at 25. So this is 50. This is actually 25. 25. Yeah. This is mistake. Offset 25. Yep. And then I remember these buttons here be 25 by 50, but I actually want my buttons to be a square. So I'm going to use 30 by 30. So I'm just adjusting this note here. 30 by 30. Let's do that. Offset again, 30. And this will give me my thickness of my buttons. All right. So let's come over here and deal with this. I project that up. I trim. And I trim. Let me just put in the fascia one time. The fascia board is 25 mil, which is here. I know I have it at 50, but I need to change. You know what? Let me change it. 25 mil, and that means just about that. 25 mil. Right. So I kind of just offset this on the fly, adjust that on the fly, although that's the one that we're not working on. I just wanted you all to see the example looking perfect, even although I'm working on a new joint or new details. So let's go here. Alpha line, and I'm going to bring this down just slightly 25. I don't like that. I don't like that to be on the edge. Okay, that's good. So that's my fascia in. Now I am going to put in my close boards. So I'm going to alter my close boards here, and this is going to be 125. That's the distance. Yeah, 125 by 25. We'll offset this a couple times up. Okay, that's good enough for me. And now I'm going to come back here, and I'm going to create my buttons. Put the X through them to show that we are cutting through a timber member. Yes, these close boards are timber members too, but that's going to be represented in a different hatch. But when you cut through big members, we use the X. Sometimes we use the actual timber hatch. So you use both of them, so we can express the detail properly. Now I'm just going to trim here because this needs to be trimmed. No, let me trim it properly. Here, trim here, and trim here. Good. All right. So that is done. Now, what else do I need to do? I need to put the roof sheeting onto this now. I'm going to express my roof sheeting at 5 mil. So I'm going to offset that there, 5 mil. I'm just going to pull a line out here, and then I'm going to extend that to there. Let me just clean this up. Okay, about 25. The reality is I never bring my roof sheeting to finish at the edge of the fascia. I project my roof sheeting slightly over the fascia board. Let me explain why I do that. I do that because I also want to protect the fascia board. I don't want too much water to be going around here. I should use a different color so that you can understand that. I don't want too much water right here at that point. So when I project my fascia board, my roof sheeting, a little longer than usual, I protect that area. So what happens is the rain will fall and come and fall here, and then it would flow into a gutter right here. So that means all underneath my fascia is protected because it won't be actually receiving any water. By extending the metal sheeting over the fascia, you protect the fascia. So that is why I do that. Now, that is done. The next thing I need to do is I need to hatch this detail and put it into the respective layer. So I'm going to do a simple match drop. For those of you who see me match drop, you would understand this technique now. So I'm just going to place any random hatching there, a random hatching here, 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 and another random hatch there and there, and now match drop. In A, grab what I want, bring it there. This is how we express timber. And we are cutting through small timber members. When we cut into large timber members, we express them with an X. I hope this doesn't confuse anyone. Now, what I need to insert is the hurricane strap. And then this detail is complete. I need to probably place this another location for support. So finish it there. Yeah. Now I just keep my hurricane strap very random and loose, meaning that I don't have a specific dimension for my hurricane strap. But if I want to get very technical and see the correct dimension, I can come here, and this is 2.5 thick. So that doesn't give me all that I need. What else would I need? This. You can go and research it, but I just really, just wing it. I'm not ashamed to say wing it, because once you actually specify what is it you're doing, you're good. Once you call it the fuzzy note, this is a hurricane strap, you're good. Make it look like the hurricane strap, you're good. They're just creating the holes. You can put them at radius 5. Put them in the hidden there. Yep. That's good. That's my hurricane strap, and I'm happy with that. No. I'm not really going to label, because the labels are here and everyone can see the labels. Well, what am I going to do? I'm just going to place these in an outline layer, and then I'm done with this. And then I move on to the isometric projection of this detail. That's it. So that detail is finished. And this is a timber pitch roof wall plate detail. One last thing, I'm going to change this into a closed eave by placing the timber here. Okay. So that's my closed eave inserted. Let me just place a hot chair so as we can represent that timber member. Cool. This side I'm going to hatch the wall just to represent the bricks. Cool. We got our bricks in. That's finished. That's the finished detail there. Hope everyone understood that. Now I'm going to move on to the isometric projection. What can we take away from this detail that we would need when we are generating the isometric projection? I think I'm going to copy this detail and bring it out here so that they can reference it. And just bring it right here. Yes. Let me just move all of these. Cool. All right, this feels better now. Now, first thing, as we're about to start this isometric projection, we need to change my tracking. I'm going to change this to polar tracking and make sure that you have on the 30, 60, 90, 120 angles when you turn on your polar tracking. So I turn on polar tracking, then it's on, it's in blue, and go. Alpha line I project up, which is 90 degrees. Distance doesn't matter to me. And in this, we cannot offset. So although I want the distance here to be 150, I have to put in 150 to get the proper distance and then project this upward. It cannot offset. Without offset will give me a skewed distance. So I'm just letting you all know that. Never offset when you're drawing your isometric projections. You will get a skewed distance. You only offset in orthographic projection. So now I want to go up my beam. I remembered my beam was 275. 275 up. Connect that to there. It's a beam. All right. I also remember that I had the layer plaster. So what I can do is I can grab this line and copy it. Copy it out 10 mil. Yeah, and I can grab this line and copy it out. And that goes 10 mil again. Yeah, very good. Next thing I want to do is I want to place my wall plate in. So let's have a look over here. We're going to put in this wall plate. This wall plate comes in at 100. You know what? I want to trim these. Although I'm going to put them back there. 100. There you go. That goes up 50. That goes across 100. And then back down. Trim. I need to set it up on the other side. And I remember, let's just move that to there. Perfect. Perfect, perfect. What else do I need? This is the part that is going to be extremely tricky. This is the part that's going to be extremely tricky. Jet this over to here, 300. Check the line up. And what I need to insert now is my angle for my roof. My roof angle here is what we need to insert. So I want to get this line. I'm going to reference this line and see what's needed. See how this is inserted. Because this part here perhaps would trick anyone. How do you get this line? How do we create a 30-degree angle on an orthographic projection? Let's go. So I come here, angular, and that is 7 degrees. So from a straight line, I now want to say set at 7 degrees, I would get this line here, and then I can actually work the rest. So that's 7 degrees. So what does this mean? This means that I put a straight line here. This means then that I go up here and I punch 7 degrees. Yeah. And that's my line. That's my line. That's my reference line that I always be using. And I extend this line through here, and that touches my overhang. So I know that it's not going to go past that point. I'm going to trim. And what I can do is grab these lines, and I know I can copy. So I'm copying, I'm pushing this up, and I'm copying this going up 150. Yeah. Then I'm going to join here, J for joins. That's it. And I'm also going to fill it. And start. So that's already in. But it's in, but it's not in the right place at this moment. And I'll explain why. If we look here, I have a slight thickness on my wall plate that I want to reflect so that we can see where the hurricane straps are inserted. And you can see that these are the pins to the rafters, and then these are the pins going down to the wall plate. So what I want to do is I want to give my wall plate a thickness. What do I mean by thickness? I mean this is the thickness. I want to give it a thickness, express it with a thickness first before I place the rafter. So let's go back here, and I'm going to give the wall plate a thickness. That's an easy fix. It's just project it on that line, that 30-degree angle, and then I'm going to give it a thickness of 50. Yeah, 50 is good. Then I grab this and that, and I can copy it from this point to that point. And I can do some trimming. I tend to trim as I draw so that I wouldn't confuse the audience. Now, this is where I'm going to move. And this is going to connect directly at that point here. So I'm going to move this to here. Yeah. I think so. Yeah. All right. You also need to give this thickness going back too, just to match that. That needs to be trimmed. All right. So we can see that thickness there being expressed. Okay, so done. All right. So now I don't have that. Okay, so that could be there. Now, putting on the close boards, we not just goes up 25 mil. And then we're going to copy that there, there. And then this goes up 30 mil. And we're going to copy that there to there as well. And in this one, we're going to copy and we're going to array. Now, the first one I'm going to copy this distance of 25. That's 125. Right. That first one is 125. And then what I'm going to do, let me just see something. Yes. Before I copy. So I'm just going to repeat the same copy process, just that I realized that things weren't done properly. The copy, go to array, down here, it says array, you get the array, then I'm going to put 7. Yeah. Cool. Those are my close boards that are inserted, not a problem. I don't like the angles, so I'm just adjusting these angles. We don't get the angles of the close boards look realistic to represent the isometric properly. So just removing the old lines. It's a good thing I'm doing this to recognizing that some things are doubled up. And I don't want that. All right, that looks more convincing. Now, then I'll move this 13. Copy. 13. So that's my bottom slash laugh slash purling. And those are easy done. Now the last thing that needs to go on to this is the roof material. And again, I always exaggerate the roof material so that it looks proper. So I'm going to put this up at 5. Imagine that's my 5 mil there. Well, look at how thin that looks. Look what thing. Ten. Place it at 10. And I think that's it. So everything is in now. We just need to make this look more convincing that it's a 3-dimensional shape, a 3-dimensional object. So the first thing is I'm going to bring this down, stretch that down 25. The third, this is a thickness now. That goes up there 25. And then that goes all the way up. Now, this extends. The X, that extends. There. Yeah, that extends. I'll probably give myself, let's say, 50. Down. Feel like that. Right. Now, I think that's too much of an overhang. So just go 25. Yeah, cool. That's a good overhang there. Now this goes back in this direction. This needs to be trimmed right there. And that goes there. So that receipts. That, mhm. So that's a detail done, but the difference is I've actually placed in the rafter. Let me just put the rafter here. And we know our rafter is 150 by 50. Come on. Good. You got in the rafters. Yep. Think that we, you know what, I'll give this some distance here so that things could be extended to that and we can see more of this detail. That's usually what I do. Copy this somewhere, probably even to this. Right to this. Uh, yeah, so this will end the roof. All right. Whew. Okay, so you saw what I did here. This is what I did on this one. I projected this down. That's where the beam comes in. But then they had a line right here. Just in case you want to end off with these lines, cross the lines go into the. All right. Now, all that's left is for me to hatch. Hatching and max dropping. Good. Lastly, put these in an outline layer because they're finished and I want to express the outline thickness, saying that we are cutting through a detail. All right. Let me just change this as it had changed while I was drawing. And now, so what's the difference between the detail that I have referenced and the detail that I drew? The main difference is the scale. So I think I should scale this, FC to scale, enter, select the whole object, just find a point and just increase. All right. Now I'm going to type in how much I want to increase this by. I want to increase this by 2. That's it. So I can just increase this by 2. So hit scale. Let's do this again. Type, start pulling, and type 2, enter. That's been increased by 2. So I think that this brings us to the end of this presentation. What did we do today? We created an isometric detail. And then we created an orthographic detail of a roof. Here are the notes. So let's go through the notes quickly. Here's where you will find the block wall. It usually comes in at 150 mil. Here's where you will find the plaster wall. That comes in at 10 mil. This is the concrete beam. This is where the wall plate would be, directly above the concrete beam, which comes in at 100 by 50 mil. The hurricane straps. Those are usually 2.5 mil thick. Here we have the rafters. This is 150 mil thick by 50. Now we have above the rafters, we have the closed boards, which come in at 125 mil by 25 mil. And directly above those are the lafts, battens, or purlins. Those are 3 names that they go by: lafts, battens, or purlins. And I have mine at 30 mil squares. And directly above that is my aluminum sheeting, which is the metal sheeting, the galvanized, the permaclad, whatever you want to call it, the roof finish. And I have mine in at 5 mil thick. What I've also done is I've created a closed eave here. So I've closed the eave so that no birds or nothing can live up in my eave and it wouldn't get dirty. All right. So that's what I've done. So this is the orthographic detail, and here is the isometric detail. Yeah. And the last thing that I need to do is I need to put in my hurricane straps. Okay. And again, I don't spend too much time on these. Yeah, I said don't offset, but for something like this, I don't really mind because look at what I'm going to do here. Right? So I got times where I do offset in here, like something that is 2.5. In other words, to get on, I can care if this is 2.5 or 3. It's just representation. So a small number like that, I would take a chance on offsetting, right? Because no one is going to be building a detail based off of my measurement here for this hurricane strap. Now, I need to put the circles in. Now, these are isometric circles. Ah, boy. I'll create one isometric circle and then I'll copy the rest. All right. So to create the isometric circle, you create an isometric box. I'm going to create a box of 30 by 30. The box usually has to be a square. It has to be a square. This is the isometric box. We always go through the longest diagonal, which is here. Sorry about that, folks. I'm doing this really quickly because I have a tutorial on how to do this on my channel. So I'm just not be spending too much time on this. If you know it, you know. If you don't know it, I advise you to go back and find it. Yeah. Straight up. What I can do is I can place the link at the end of this video where I can place the link to the tutorial that I explain how to create this isometric circle. I can place it at the end of this video so that each student will be familiar how to create the isometric circle. Okay, so I created the isometric circle on the wrong face, not a problem. Mirror is going to save me. Move there, and I'm going to put that there, right? Some people might say, well, Raymond, that looks a bit large. No problem, I'll just scale it down. Scale it down, and I'm going to scale it down by 0.5, right? Yep. So that looks good. And I'm going to copy this now. So that's the top one. It's going to be one at the bottom. And all right. I'm not going to waste time creating the circle there. I'm just going to grab it from here, right? Yep, because I'm bad like that. But you folks, you got to draw it because you don't have any circle to copy. Yeah. So those there are my holes to indicate that my, I'm going to remove these and put in these ones. The folks that watched it, that just saw me demonstrate how to create that isometric circle, consider yourself lucky. Yeah. So I've just demonstrated how to create an isometric circle that I didn't even use. So consider yourself lucky for getting that information. I hope that helped you all. I think that is it. Now, before I shut off the video. All right. Well, this was a long tutorial. I hope everyone understood. I tried to create this detail and had the reference next to me so that we can always see what I'm doing and what the final product will look like. I've also done this in a three-dimensional format so that you all can see. As we look at this for the last time, you can see the wall plate, we can see the rafters, we can see the beam, we can see the plaster wall, we can see the gutter, we can see the closed boards, we can also see the button, and we can see the roof material, the final, galvanized, and the gutter. Now this brings us to the end of this presentation. I hope everyone understood this. Please take this in small chunks if you're having trouble. and practice. I would also encourage you all to share this with others that might be having problems creating this roof detail. Until the next time, I am out. Take care.